In the previous video, we have learned all the steps that are necessary to calculate the big O time complexity of a program, or how to measure the efficiency of the program using big O notation. Now, in this video, we are going to clarify the concept using a small and simple example. So in order to do that, consider this simple algorithm example. Here we want to print all the even numbers between 5 and 9. We want to write the algorithm for that, and then we have to calculate the time complexity in BigO notation for that algorithm. So here in step 1, actually you can find the algorithm in here. So as you can see, I have initialized a variable called count equals 5, and then I have done a loop like while loop, which is iterating when count is less than n. As long as count is less than 10, the loop will iterate over. And if that number, I mean the count, is even number, that is the remainder of count and 2 is 0, it will print that okay, it is an even number. So this is the simple algorithm to count the even number between 5 and n. Now first you have to find out the most dominant operation inside this code. I have seen a tendency in many of my students that when considering the dominant operation, when finding the dominant operation, they only consider the direct statement like print or some calculation steps, something like that. They really do not consider the branch statement. Never, never, never do that mistake. Dominant operation means dominant among all. It can be straightforward statement like print, or it can be a branching statement like if. For example, in this case, if you consider this print statement, is it executing all the time? I mean, in each iteration of the loop, for all the iterations of the loop? Well, no. It is executing only half of the time. But which instruction is executing all the time? If you see that this if operation is actually executing all the time the while loop iterates. So the most dominant operation here is if count mod 2 equals 0. So whenever you will try to find the dominant operation, consider the branch statements also, and then try to find which instruction is executing most of the time. Well, after finding the most dominant operation like this, now it is the time to calculate actually how many times the most dominant operation executed. So if you find in here, you can easily realize that the most dominant operation, that is this if statement, is actually executing n minus 5 times, because the while loop is iterating between starting from 5 to n. So you got this. What is the next step? Next step is to express that t as a function of n, that is the number of data items. So what is going to happen? So this is actually very straightforward. So t equals n minus 5. You can write like this. Then the next step, if you can remember from the previous video, the next step is get rid of all the constants. So what is the new equation? Here actually we need to get rid of the constant terms, means here only one constant term is there, that is 5. So you have to get rid of that. So your new equation is now t equals n. And finally, you have to find out the fastest growing term. Now, in this case, it is very simple. There is only one term of n, that is n. So, the fastest growing term is, of course, n, because there is nothing else here. And that is why the time complexity of this entire program is order of n, or you can call it big O of n.